Okay, it's me again, Jean-Louis Van Belle. I've introduced myself in past videos, but very briefly, I'm an amateur physicist. I'm a bit of an older man. My journey started, I think, 30, 40 years ago, reading popular books on physics, and then about 10, well, 15 years ago, I started reading the serious stuff and found, just like, let me pull her up, Sabine Hossenfelder, that there's a lot of stuff that doesn't make sense in what is supposed to be, the king of science. If mathematics is the queen, then physics is the king. The king is in bad health. I want to do what I usually do in a video, and that's sort of to promote, a bit my papers. I get a lot of reads, but I want to get more. I published two new ones, and what is interesting in these ones is I engaged very heavily with the new generation of ChatGPT, ChatGPT 4 and ChatGPT 01, both in its mini version as well as in its preview full-blown version. I'm quite ecstatic about it because here are the lectures, building blocks for the ultimate electron model. With ChatGPT, I managed to finally work out some equations, geometric factors that may or may not explain the anomaly in the magnetic moment, and it worked fine. I'm really amazed at how intelligent it is. You need to control it. You need to clearly say, okay, these and these are my assumptions, because otherwise it will bring in other assumptions from what it from its knowledge base, and that's often then quark theory and other stuff. Building blocks for the ultimate proton model. There um, I did the heavy lifting, I think, the visualization. Very extensive chats. They're mentioned in the papers, by the way. So the new proton model exploration discussion, or the 3D model of a proton, or theory of a reality exploration, as I call it. And then the other titles you see here under, Thomson scattering, the magnetic moment of a sphere, discussions on gravity. It is very intelligent. It's very sharp. It does make mistakes, but if you find them and you correct them, then it often leads to fascinating new stuff. So what I'm gonna do in this video is two things basically. One is I must admit I'm a bit tired of myself and the discussions, and there's so much stuff being produced now. I get emails saying, "Oh, can you look at this paper? Can you look at that?" I can't. I don't have the time. I also think sort of I satisfied my own curiosity. I think instinctively, human beings, as opposed to artificial intelligence like Chat GPT, we do want to. We have the spiritual element in us, and that means that we want to know if reality makes sense, so to speak. We want to have a theory of reality. That sounds very crazy, so I will not say more about that. But that's what drove my research, and I think I'm there. I mean, there's a lot of more work that would need to be done. So I think I have now a very clear set of principles and laws, and they're rooted basically in Maxwell's equations, classical electromagnetism, and then the quantization of energy, of charge in its most primitive form, of precessional motion of a ring current, quantized magnetic fields, all the things that explain like superconductivity and other phenomena. It confirms that sort of quark gluon, all the modern QCD and QED and quantum field theory works perhaps, but is not really needed, and leads to sort of new metaphysical concepts that should have no place in physics, in science, infinite causal structures, virtual interactions that we can never observe between equally virtual photons and electrons. The term that got invented, the fabric of space-time. Space-time is just, I would say, the theater in which things happen, but it's not a fabric. It doesn't have any ether-like properties. There is no cosmological constant. Einstein was right that he said that it was the biggest blunder he made, because he fueled the sort of etherization, I would say, of space-time again. Or, fibers and spinors replacing the elementary concepts of charges and field. And I say charges, I mean electric charge. There's only one charge. What I did find is that mathematical techniques that are used in these modern, my view, nonsensical quantum mechanical theories, the mathematical techniques are very useful. And I will talk about it in the second part of my lecture, where I'm going to talk about my proton model and what I found out, and why my new paper on the proton model is perhaps a bit more interesting than the previous ones. So we're going to talk about, you will probably switch off by then, quantum mechanical oscillators and coupling between them. A lot of work remains to be done, of course. I said, my eagerness to understand what an electron and a proton really are, what their structure is in terms of charge and electromagnetic oscillation, would need to lead to a neutron model. Neutron is, as we know, unstable outside of the nucleus, but somehow we think of a neutron in light of its mass energy, which is only slightly higher than that of proton, as capturing a negative charge in some neutronic neutral combination of a positive and negative charge. And then we would need to move to the neutron model, where this negative neutronic charge seems to act as we talked about gluons, but it's charge and unit charge as a glue between two positively charged protons. In interactions theory, there was a lot of work that has been done on, I think, a lot of thinking in my papers on how a photon, or first what a photon also really is, a point-like oscillation, but with a linear frequency, not like matter particles that have orbital frequencies. We would need to extend that to sort of the counterpart of a proton, or nucleons is the neutrino. If we think of nucleons as three-dimensional oscillations rather than two-dimensional oscillations, neutrinos are likely the same. And I hypothesized a lot on that, saying that neutrino probably has some inertial mass, or a rest mass, because it's also an oscillation. It's an oscillation in 3 dimensions, and one of the dimensions is, of course, its direction of motion. We need to connect low and high energy physics much better than we did. I wrote it. I think the theories that involve color, flavors, quark gluon theory, are related, this triadic scheme, ultimately to the 3 types of charge about I talked. There's like an electronic charge, which explains an electron, a protonic charge. They're not each other's matter, antimatter counterparts, and then this neutronic charge. So I think there's a lot of interesting stuff that can be done to, I would say, reinvent quark gluon theory. On that, maybe very quickly, I will talk about resources. I get a lot of updates from Science, Nature, and Physics Oxfam. It's one of the very few paid subscriptions that I have, apart from all my software subscriptions as an IT professional. I usually have no idea what to do with them right here, but there's this update on count decay modes, or that in the 60s, 70s were supposed to be not happening, and based on which they invented all these new conservation laws and quantum numbers. What strikes me with that is that it appears in a briefing, physics.org, Nature, and there's like no obvious conclusion that hey, if this experiment proves that quark-gluon theory, which is based on other experiments that supposedly prove that this or that cannot happen, and now it can happen, why doesn't that lead to a very fundamental review of everything that came with it? These hypotheses of a strong force, weak interactions, etc. So explanations that are not being phrased in terms of classical electromagnetic theory, basically with the only two quantum mechanical laws that make sense, the Planck-Einstein relation and Einstein's mass-energy relation. When I say Einstein's mass-energy equivalence relation, I mean it, these models, these Zitterbewegung models are mass without mass models. Mass is really interpreted in one sense only. It's the inertia to a change in the state of motion of a charge, or the motion in a field. Don't think of a magnetic dipole field being generated by an electron as a static thing. There's motion in there. There's motion of fields, and so there's an inertia in when you want to change that state of motion, then you need extra energy. So it's an explanation of mass, not through Higgs or scalar hypothetical particles. So, but yeah, the problem is a lot of Nobel Prizes have been given to not to theories that confirm the old theories, but to more mysterious new ways of doing things. Like this Nobel Prize in 2011 for work on the supposedly proves the cosmological constant. So today we're 2024. Well, new measurements on the rate of expansion of the universe, as reported by last month, question the measurements which led to that 2011 prize. So, is anyone bothered by that? No, I guess maybe me because I'm old-fashioned and I wonder what's going on. Gravity. So yeah, look at the blog because that's probably what I am gonna limit myself to over the next 5 or 10 years because I said this hobby of mine has been eating up too much time. Work ahead maybe also is if I would have time and energy left, but it's limited in my life as opposed to the time and energy apparently in the universe or on research aids is examine form factors. I talk about in this paper on the proton model, actually also about how Zitterbewegung theory would apply to unstable particles like the muon. That's that annex, and the tau electron, which apparently is completely off in terms of its energy, phrasing it in some kind of h, Planck's constant times frequency. So that's why it's probably a resonance, why its lifetime is short. So 3 generations, it's one of the problems in physics. I think of it as, we have stable particles, elementary particles, we have combinations thereof, and we have unstable, call them elementary if you want, mu and tau electron. I said the neutron outside of the nucleus, and then we have these equilibrium states where some combination of charge and the fields they generate falls apart into more stable constituents. Annex 4, I'm going to talk about that. My model of proton, electron perhaps too, but I'm actually pretty confident it's relativistically correct. But my proton model is heuristic, and I'm going to talk about some relativistic corrections that may or may not make it the final or ultimate proton model, as I call it here. So that's the first part, actually, where I say, well, goodbye, guys. Think for yourself. For the resources, read my papers on ResearchGate. I want to be read. I wrote them as working papers because I do not bother as an amateur to sort of get into a journal. You just don't get past the review of your CV. I'm a philosopher. Have a degree in that. I'm an economist. I published in other fields, but you just don't get a good paper on physics in a journal on physics if you don't have the required pedigree, which I don't have. The Zitter Institute is very nice. I think of it as quite an honor that I'm not part of, being invited to sort of be part of this eminent group of people who do believe that a local and a realist interpretation based on the Zitterbewegung hypothesis, that is called. Let's go back to Schrödinger, which was revived by David Hestenes here on top in the 90s, Zitterbewegung interpretation of quantum mechanics. That makes sense. So my name is on there, but if you go to this site, I would recommend it. Read the newsletter. The links are nice. Classical bivector net. Reading Feynman, my blog. I'm very pleased by that. Yeah, but go to the site to read alternative views to my particular pet interpretation, I would say, of Zitterbewegung theory. In terms of other resources, I'm currently reading up on geometric algebra, realizing that I've used sort of a heuristic approach combining electromagnetism, Planck-Einstein law, and then plane geometry. Maybe that all comes together in what is referred to now as a geometric algebra or space-time algebra. And I just got the book here, Unified Field Theory and Occam's Razor, which is written by, well, I don't know Paul O'Hara, but good old Professor Celani from, known very well in the field of low energy nuclear reactions, Eddie Tommaso, especially Dr. Vasallo, who inspired me a lot. And then what I think is a genius, Andras Kovacs, amazing volume of papers, and this book just came out and he's already working on the next one. So I'll try to get through this one, and it will probably take me a lot of time and energy, which I don't have then to develop my own theories, which is great. Going to the Proton model, I said that's the second part. I'm going to be brief on that. Yeah, I said we have this for the electron then, Planck-Einstein relation. Energy is somehow, it's quantized, and the quantization is given by, energy is a force working on something, an oscillation, linear for a photon, orbital, or and so it's the quantization is given by Planck's constant times the frequency, or h bar, Planck's constant divided by 2 pi times the angular frequency. Applies very nice to matter particles. We get the Compton radius for an electron, and I said I talked about the theory of mass that comes out of it, the idea of that Zitterbewegung charge, the small charge, the Thomson radius, or classical electron radius given by the fine structure constant, is the kinetic energy of that Zitterbewegung charge is half of the total energy of the electron. The other half is in the electromagnetic field. And then we have this model of two independent oscillators, and one in the x direction, y direction, where magically, classical and relativistic oscillators come together and add up to, an equation that says the energy is a mass factor, the effective mass, all relativistic. That's how mass emerges, I said it, and mass without mass theory, times the square of the amplitude, which is the Compton radius, times the frequency squared. So now we try that on a proton. On a proton, we find that in 2019, it says a lot of good stuff happened over the last 5 years, discovering really the essence of gravity and measuring this proton radius, where you get, that struck me immediately, a radius that is 4 times equal to h bar times c divided by e, 4 times the equivalent. We substitute the energy of the electron by the energy of the proton, so we get like this modified Planck-Einstein relation, which says 4 times h bar times the frequency should add up to the energy, and it's this geometric factor that we have in the formula for the surface of a sphere as opposed to the surface of the circle. So that intrigued me a lot, and based on that, I'm gonna, I have a lot of equations here. Yeah, I developed this, Zitterbewegung. It's a Lissajous curve. Let me pull up maybe, no, not that one. This is a sort of an oscillator model. Here I model 3 linear oscillators working together, same frequency, but separated by phase difference. Think of the engineering metaphor of a radial engine with 3 pistons. But it gives you an orbital. So here we have another kind of, we have this 3D oscillation in 3 dimensions, same amplitude. Along the Z, X, and Y directions. Probably, if you want to put it on a sphere, then this is how it looks like. So going back, I said I played with ChatGPT because it's much better and useful to sort of directly calculate the angular velocity vector or orbital frequency in terms of spherical base vectors. We get very sensible results when we equate polar azimuthal angles. We know we have r, the radius, polar angle, azimuthal angle. We get a constant angular velocity, but there's this factor 2, well, square root of 2, but it's a constant. Now, the remarkable thing is, then I thought, hey, we're there, we're done. But we aren't, because then I thought, okay, can you now calculate the velocity vector? We want to get a tangential velocity vector that is equal to c, light speed. And there, you have an x component of the velocity, a y component, and a z component. It's the time derivative with respect to the 3 position coordinates. You can immediately see we get that's where the problem starts. R times omega is c, but it gets, that's normal. It varies between, it gets multiplied by a factor between 0 to 1. Here also it's a sine, but you can see here we have a phase difference of between a cosine and a sine of 90 degrees, and so it's kind of artificial, our model, in the sense that it leads to the Vz component, the component in the z direction of the tangential velocity. We don't have that factor 2, just have that, so we have a different functional form. And that's where the calculations are going to be brief, and then you can read the paper, lead to, this is the formula for the magnitude of the velocity vector, r times omega times this square root of 1 plus sine squared times Wt. And Wt, we can write it as, is the phase of the polar angle or the phase of the azimuthal angle. So we get a minimum and a maximum. And what we get is that, on the equator, further clean up, don't get too busy. Okay, that's done. On the equator, here, the equator, now you're looking, the center of the sphere is the equator, and this is the pole. On the pole, we get a very high, higher velocity. We get this velocity light speed times square root factor 2. That's not okay. How can we explain it? It's interesting, so I'm gonna talk about it, should be short. But if you have two components of a velocity vector along x and z directions, and let's suppose this is equal to c, and this is equal to c. But yeah, the particle happens to go in this direction of the xy plane, then the magnitude of this vxy vector, I would say, velocity of the charge in the xy plane will be the square root. It's just a Pythagoras theorem. Square root of sum of squares, and it will be larger than the value. So we have something like this. So I'm not going to talk too much about it, but it's clear that my heuristic model is not relativistically correct. It is still a nice model. Alternatives is, you can think we can adjust the R and R parameter or the frequency. We can replace it by, R over 2. Again, looking at the curve, from the Z direction, it looks like we have like an effective radius that is half of the radius of the sphere and would explain its magnetic moment. So it's tempting to do just that and say that, we replace R by R over 2, an effective radius, or we replace the frequency by what we found is that frequency of the angular velocity vector is 1 divided by square root 2 times this W in the equations, or we use Planck-Einstein relations and divide the frequency by 4. Energy divided by 4 times h bar. Yes, that reduces the frequency, brings angular velocities down, but it doesn't yield, it doesn't solve the issue in the sense that we don't get a constant tangential velocity. So we should try different functional forms. I said we tried that one where we have a sine, the same frequency, and then a phase difference to account for the fact that we have 3 oscillators rather than 2. That yields that, what is it here? Oh, that's interesting. I get a slightly even larger, that's interesting. I hadn't seen that. Now that I put the sphere, I get a circular orbital, but so slightly larger. It's interesting because I was talking to ChatGPT and asking it to sort of adjust the radius to sort of make sure that I get a constant velocity. It also arrives at a circular orbital, which I don't want, but it's interesting that the visualization of it leads to what ChatGPT writes in formula. It's a bit unfortunate that AI cannot immediately produce, but I think it's instructive, and that's a lesson I want to give to you also. Is work with ChatGPT, but double check, visualize to see if what it writes makes sense. I'm saying it because there was a bit of a mess up with a wrong formula that it first used to calculate that angular velocity. I'm rambling a bit, so let me wrap up. The interesting thing is here in these coupled oscillator models, where we would have a cosine, a sine, and cosine, but we combine 2 of them in the xy direction, let's say, into the idea of a circular oscillator, which would then have half of the total energy of the proton, and then all the rest would be in this linear oscillation. It's a bit like this idea of an accordion, and then we try to stretch it out in this direction, and then and now we go back and get something like this. Now this doesn't work because the velocity here is in this direction 0, so it will be more something like actually what we get on our Lissajous trajectory, reaching the full radius and then going back. All energy is in the linear direction, in the linear oscillator, the Z direction, and then it stretches out again. Interesting. But as said, I have the link to these public chats. It's also not the ultimate model. It just shows us that probably we need to go to a coupled oscillator model with, in 3 dimensions. And that will give, I tried this one. Did I? Yes. It's a question of parameterization and all that. The coupled oscillator model would bring, relativistic corrections, but these are not very regular trajectories. They oscillate a bit wildly. ChatGPT has produced numerical stabulated values based on the real values or approximations of it, proton radius of the order of 1 femtometer. That Zitterbewegung oscillation of, 10 to to the power 24 per second, radians per second. But it doesn't yield immediate results, and that's sort of where I'm gonna stop my lecture and say, yeah, I think this is the future. At the same time, what I said here, then once you get that right, based on an oscillator model, you do need to see this trajectory, these equations of motion for the proton. Would it really yield the measured radius, the interaction radius with other charged particles that are used to that scatter off the proton, moving electrons. There's several, I'm not going to go into detail. There are like two major approaches to measuring the radius, but they yield the same. And the magnetic moment. So that's sort of what I say, why I want to read more and stop writing and talking on this geometric algebra, which somehow, needs to bring together EM, Maxwell's equations, the quantization given by the Planck-Einstein relation, and plane geometry. In one consistent mathematical description of physics. I leave gravity out, so grand unified theories. I saw, I quoted, what is it, Hossenfelder? I see that here. A new theory of everything just dropped. I thought she wrote theories of everything have been dropped. Gravity is not, there's no such thing as quantum gravity, but that's a personal remark. Let me see where I am. I'm at half an hour. I think that's sufficient. I'm gonna do as usual. I pulled up some, do play with the Desmos. Yeah, this is, things like this correction factor that you get out of the equation. Do check them here. I do it linearly. It gives that variation between for the blue curve. Yeah, I don't have the factor 2 between 1 and 1.4.1, and when you add the factor 2, yeah, we get what we expect to get, a variation between 2 divided by square root factor 2 and 1. So that's a sanity check. I did other sanity checks in the with ChatGPT. They're easy to do. They're very quickly. I asked them to calculate, for instance, the length of this Zitterbewegung trajectory, and to see if it's consistent with the velocity calculations that it made. And it is. So it is a good heuristic model in the sense that there are no, I would say, inconsistencies in it from a mathematical point of view. But yes, it's a very classical model, and I think there's a problem there. I want to talk about that a little bit in these oscillator models. If you have two independent oscillations, or 3 or 4, you see that somehow magically, it doesn't matter if you use relativistic oscillators or just a classical oscillator formula, which is given by 1/2 the efficient mass. In any case, the efficient mass, effective mass, not efficient, effective mass is relativistic anyway. So the relativistically the relativistic correction that you would need to bring to a mass factor are in there already. So they somehow magically come together in the oscillator model, as I call it, and the electromagnetic or Zitterbewegung model. But you don't have that in you don't have that here. You end up with these corrections where you still say, okay, I have a cosine, I have a sine, I have a sine, but I have different phases or frequencies. It's going to be a more complicated formula in 3 dimensions. You kind of lose that easy equivalence between oscillators models, linear oscillators in 3 dimensions that give rise to a planar 2D current, And then what we want to have here is a Zitterbewegung trajectory. It's not going to be solved by easy sine, cosine. Let me pull this up a bit. Here. Yeah, a cosine as the third coordinate, and as a product of sines, and then product of a sine and a cosine. It just doesn't do the trick. So it's probably going to be complicated and not for me to solve. What else did I have? Yeah, my blog. I said, I mean, it's probably the main thing I wanted to say. You know, Paul Erefest, he's a very enigmatic, brilliant figure. He followed Hendrik Anton Lorentz, about whom I write a lot in my more historical overviews of where, you know, all this nonsense came from. He complained about indigestion from the unendliche Heisenberg, Born, Dirac, Schrödinger, Wurstmaschinen Physikbetrieb. So I'll let you translate that, the sausage machine that modern physics has become. Yeah, that has, we're 100 years later, 1933, almost 100 years. Yeah, he seems to have gone through the trouble before he killed himself of summarizing his questions in what an article which was then one of the top journals for physics, Zeitschrift für Physik, einige in die Quantenmechanik betreffende Erkundigungsfragen. It's kind of hallucinating to sort of, as an amateur physicist, see like, well, this guy got difference between him and me is we were asking the same questions, but he was an academic and had to you know, follow the mainstream. I would say these are good advices, and but stay far away from the madness that you know, thinking in the night about this or that model might bring. Don't take it too seriously. I talked about that, new discoveries that are made that invalidate all theories, and then for some reason nobody bothers. All my chats on physics with ChatGPT 01, I said I'm happy with them, but they're public. You can continue them. Scroll through them, you will see ChatGPT does make mistakes, but when you manage to correct them, it's very quick and very rapid to calculate stuff, and like this non-constant tangential velocity. I hadn't seen that before, or noticed or thought about it or derived it before ChatGPT gave me the equations that came out of my model with very limited assumptions. And then I said the Zitterbewegung Institute, lots of resources, good books. I think read good books. I read very few articles, but I buy books. I just bought this one. I have a pile next to my desk. The classics, Dirac's Principles of Quantum Mechanics, especially the last and fourth edition, where he revised chapter 12, and you can really see how disappointed he is with how you know, his theory got a bit subverted. I mean, that's my interpretation of the very fine remarks he makes by reading between the lines. And that will be it. I thank you, and I said this might really conclude my my video series. It is fun, keep it fun, and do what I wanted to do with this thing. Is this is the title of these lectures, building blocks. So I tend to think the most important, Feynman, and you know, I agree and disagree with Richard Feynman. I think there's a need for empowering you know, people like you and me, amateur physicists, sort of you know, get them good building blocks, like you know, how does magnetic precession work, how is it quantized, and use these building blocks. Said I only have my most read article 16,000 reads, plus, you know, previous version. The Bruys matter wave concept and issues, May 2020, 4 years ago. It's a technical one, has a long introduction, but then becomes very technical. Geometric interpretation of the Breuil wavelength. And now wave equations, why they make sense or don't make sense. Dirac's wave equation, I take it apart. Schrödinger's electron, or the elementary wave function, as a solution to his wave functions. How, I talked about sort of an integrated geometric algebra. I think it should satisfy what I write here a little bit. When you get a wave equation, you have a solution for it. It needs to make perfect sense. Oh, this is a long paper. When you take derivatives, and solution has to be solution. So yeah, all the sanity checks that you can do. It works perfectly well for for Schrödinger's wave equation. When you leave out that 1/2 factor. I think he made there two mistakes. 1/2 factor is Schrödinger's equation for atomic electron orbitals models a pair of electrons with opposite spin. So that's where the 1/2 factor comes from. It's 2 times the electron mass, and that gets confirmed when I do work out the derivatives to calculate velocities, and I relate it to a lot of stuff here. Acceleration vectors. With acceleration vectors, I mean centripetal force, which must be generated by the electromagnetic field, the magnetic dipole field. It all works out, and so there's a very deep truth in these equations that I have here. But they would need to come all together in sort of a more intuitive, geometric algebra that combines electromagnetism and quantization given by the Planck-Einstein relation, and plane geometry. So we're not there yet, but we'll never get there probably, otherwise it would really be the end of physics as a science, isn't it? So have fun with it yourself. Go through these 2 or 3 core papers, and then develop, as I say, your own pet model of reality in the sense of physical reality. Because then the more interesting bit is then you go to chemistry and stuff, and then you see intelligence emerging as some kind of behavior of complex systems. We are probably the most complex biological system on Earth among all other animals, I would say. But now you have AI, and it's very impressive, I must say. A little bit scary sometimes, but good if you want to move forward fast on what is called in this book, simple solutions to very deep questions. And that will be it. Thank you very much, and I wish you a very nice day and a